Good day, ladies and gentlemen. My name is Anis, and I am the hydrocarbon accounting representative from PETRONAS Malaysia. I am very glad to be able to gather here today with all the other professionals in the industry despite we are having to do it virtually. But I do hope that I will be able to share as much as possible on the benefits that Sigmafine has provided to our company. So the title of my presentation today is the role of Sigmafine in improving reliability of our refinery data ecosystem. So for today's agenda, I will be starting with a little bit of introduction of our company, Petronas, and also our refining facility, the Malaysian Refining Company Sdn Bhd MRCSB. After that, I will straightaway dive into the main agenda of the presentation by detailing on the problems and solutions, our user experience, and application of Sigmafine in our refinery data architecture. Lastly, I will close off my presentation with the benefits and improvement. So hope everyone gets comfortable and let's get started. So our company, Petroleum Nasional Berhad, or known worldwide as Petronas, is the Malaysian oil and gas company established back in 1974. As of 2021, we are ranked amongst the largest corporations on Fortune Global 500. By the production capacity, we are currently ranked as the number 1 for methanol, number 3 for ethylene glycol, and number 4 for urea in Southeast Asia. And if you are a fan of Formula One, I believe you would know that Petronas is the proud technical partner for the Mercedes-AMG Formula One since 2010, providing superior quality of lubricants and functional fluids which drive towards 7 victories. Currently in Malaysia, we have 3 refining facilities located in Melaka, Johor, and Terengganu with cumulative processing capacity of 727 kilobarrels per day. And this is where we are currently situated. So allow me to introduce our refining facility, the Malaysian Refining Company Sdn Bhd, or MRCSB for short. MRCSB is a wholly owned subsidiary of Petronas which has been operating since 1994, powered by 2 main processing units, PSR1 and PSR2. MRCSB has the capacity to refine 303 kilobarrels of crude and condensate per day and also lube-based oil from the MG3 unit. As of now, we are supplying 60% of domestic demand such as gasoline, diesel, and kerosene. The latest addition that we have in our complex is Diesel Hydrotreater Unit DHT3, which started commission this year specifically to process diesel Euro 5. These units are all interconnected and integrated between each other with shared common facilities such as hydrogen supply, fuel gas, utilities, and tanks. The movements of the hydrocarbon molecules across these units are continuous for 24/7, and the movement also needs to be tracked. So Sigmafine covers the boundary of our refining process starting from first is the delivery of feedstock at jetty. Secondly, in and out movement of crude at tanks. Third, the movement of molecules from processing units into tanks. Next, in and out movement of final product tanks. And lastly, delivery of our products through the 3 mode of distribution, which are vessel, pipeline, and truck. In total, Sigmafine is able to provide reconciliation of 124 tank mass balance with average number of 4,100 to 4,600 tank movements in 1 month. Now, moving on to the function of Sigmafine as a solution in helping our organization to improve our reliability of data ecosystem. So before Sigmafine came into the picture, everything has to be configured manually through Excel spreadsheet. This definitely imposed difficulty when it came to balancing refinery data, as the hydrocarbon accounting team will need to rely on manual data entry and consolidation. And then with manual input of data, the team will also have difficulty in accessing historical data when needed. There was no systematic data architecture or system that was able to capture the data activity, tank inventory, and movements across the refinery units as in a real-time tracking. This will also greatly increase the possibility of error. Besides that, the team would face constraint in adhering to the deadline of our end of month account closure, which is on the third day of every month from having to go through various sources of data. Therefore, this called for a need of a seamless system that can act as a main platform to consolidate and collect all this data and can be given and can be accessed by the hydrocarbon accounting team. And this is where Sigmafine steps in to play its role by compiling and organizing data efficiently to allow simplicity towards its end users in accessing data whenever and wherever. So MRCSB and Sigmafine has a journey of almost 20 years together with few upgrades that have been made across the years. In 2009, after MG3 was built, upgrading was carried out to incorporate the unit into the existing Sigmafine model. Similarly, upgrades were made in 2011 and 2021 to include the PSR2 post revamp and also the HD3 unit. Next, we will go deeper into where Sigmafine fits in MRCSB data architecture. The hydrocarbon accounting team works closely with the planning and scheduling team to ensure that all of the tools that we are using in the refineries are able to communicate and cascade information between each other seamlessly and efficiently. Here, Sigmafine plays a vital role as it is the only software that is consolidating the actual activity or movement that happened in the refinery. So using the data gathered and reconciled through Sigmafine reports, they become the key indicator or basis for a new cycle of planning and scheduling of future refinery activity, which will eventually ensure optimization in terms of operation and also cost. And as we can see here, there are multiple data sources currently in use in MRCSB, such as we have the tank gauging system, the lab data system, the oil accounting system, and also PI. So all of these data are fed to Sigmafine server, which allows single data collection. From here, Sigmafine will act as a mass balance tool to reconcile and generate mass balance report for usage of Sigmafine end user, which in this case is our team, the hydrocarbon accounting team. So by using Sigmafine in terms of our user experience, it can be divided into two categories, which is the daily and also monthly. On daily basis, we are able to produce two main reports, the mass balance and envelope reports. Through these reports, we track hydrocarbon movement across the multiple units in our refinery. Secondly, we are also able to produce water draw reporting using Sigmafine by tracking the volume of water being drawn from our crude delivery. Through this monitoring, we are capable to detect if there is unusual amount of water drawn, which may compromise the quality of our crude that will be used for processing. On monthly basis, we have the Inventory Movement Report, or IMR for short, which consists of monthly reporting of tank inventory to determine the performance of three main units in MRCSB. Lastly, we have the Unit Throughput Report, which is used for financial purposes. This can be further detailed down into the work process adopted by our team from day to day and to ensure accurate reporting. By 8:30 a.m. every day, Sigmafine will complete its data transfers to the server and the daily mass balance report is ready to be generated. The hydrocarbon accounting team then will start to perform daily mass balance to ensure that the tank data is within healthy boundary through validation of data with other sources such as meter reference. Any unusual movement, activity, or volume can directly be detected and analyzed at this stage, hence allowing swift corrective action to be taken. In the end, the mass balance conducted will ensure that each material is well balanced, each plant input and output is correctly acquired, and the yield and loss is in acceptable range. At the end of every month, we will compile the data that has been reconciled on daily basis and produce the monthly and reporting called inventory movement report for submission by the third day of every month. At this point of time, it is safe to say that we can be firm and confident with our figures as we have been consistently monitoring and analyzing them throughout the month. This greatly increased the speed of completion of our reports while ensuring the reliability of the data reported. Our daily mass balance report covers several boundaries. First is the feedstock and import. Secondly, the blend stock and intermediates. And thirdly is the final product. So under these boundaries, there are a wide range of activities recorded by the mass balance report as listed in table here. For example, for the first boundary, we have the feedstock volume going into the process units. And then there is also other activities for other boundaries as well. So that we will be able to see here is that all hydrocarbon movements are captured, recorded, and balanced. And in the end, we can check the actual data recorded against the one that we have planned. We will finish off the end of process of our daily mass balance reconciliation with envelope reports that measure the plant's product yield and loss. In this report, all the inputs and outputs for that day are gathered together for calculation of yield and loss. In this slide, I have the example of one of our sub-report for our end of month account closing. In total, we have 32 sub-reports to be balanced, with one main report summarizing the overall finding. For example, in this one, we are balancing the tanks used for kerosene, and the figures that are taken into account are blending components and export of products. These data are all readily available from mass balance reconciliation provided by Sigmafine on daily basis. Hence, you are able to determine the loss incurred by these tanks. And the process is repeated for other components produced by the refinery facility. So for the second last part of my presentation, I would like to demonstrate on how Sigmafine plays vital role in acting as first in line of error detection that occurred in the refinery data ecosystem. So back in July 2021, through our daily data reconciliation, we noticed that the total rate of crude being fed into the processing unit is significantly lower compared to meter reading. This raised the need for further investigation, and unit scheduler was immediately notified on this matter. The first course of mitigation action is that we compare between the net volume and also the gross volume to check for any discrepancy. And it can be clearly seen from this graph here that the gross volume and the net volume greatly deviated from each other when they are supposed to be close to each other if the data is flowing healthily. We then proceeded to cross-check other data sources that was fed into Sigmafine server and eventually identified that the value of basic sediment and water, BSNW, is not reflecting the actual value taken from the latest sample. Through this detection, we are able to mitigate the impact of overstating or understating of volume in tank. For example, if the feed rate is actually higher than what is being monitored, there is a risk of stock out situation where planners and schedulers could not gauge the actual movement of feedstock from tanks. This may lead to a more serious impact, such as processing units have to be shut down because there is no availability of feedstock, and then there will also be no production of product to fulfill the demand of our customers. This will also lead to penalty imposed to our company. So, to conclude my presentation, utilization of Sigmafine has benefited us greatly in several aspects. From the perspective of planning, scheduling, and In operations, mitigation of error can be taken care of quickly through early error detection, besides having reliable data for optimization of planning and scheduling activity. In terms of finance, we are capable to produce accurate data that will be converted into monetary for financial reporting. The next benefit is that we are able to systematically track hydrocarbon movement to produce reliable and structured company official reports, while also being able to use the data to comply with audit requirement and also custom declaration. And then lastly, Sigmafine allows for operational performance tracking and optimization, improve feedstock and product inventory management, and also allow us to assess the actual production yield versus the planned yield. So that is the end of my presentation. Thank you for your attention.